Hello, hello. Morning, morning. Morning, guys. Morning. Jin say good night. Yeah, hello. Just finish your breakfast. You just expose yourself. Okay, good morning. Before I start, okay, look at my cat on top. Cute leh. You can name dinner. Okay. Okay, guys. Starting soon, Starting soon, Few more minutes,早安. Morning, good morning. Okay, those who managed to wake up in time, good job, good job. Okay, but we wait for a few more minutes before we start. Okay, so guys, before we start, we are using your October notes. So as usual, we're using October notes. If you realize October notes, at the back is all revision questions. Okay, so you try to go to your October notes. Wow, Joey, good morning. Good morning. See. Can see you in morning a bit different, Very early, yeah. My God, this one is like later than your normal school time, Where got early? You wanna sleep, Hiya. Sleep is for the weak, okay? Today one day only, No need sleep one, lah. Okay, guys, one more moment, Let me send some link to people. No energy, eat your breakfast. Sleep more important for study. Correct. But I bet you never study yesterday, but now study more important. Sudah makan. Okay, good job. Okay, guys. So we can actually start in a while. Okay, guys, you go. Okay, what you're gonna do is okay, you all have your October notes, right? So in October notes, what you're gonna do is you flip to the back. Okay, and then you shall see your October notes from one page on from one page with one paper become two page on one paper. Where that is the part where you start your revision exercises. Okay, so what you're gonna do is you see so here got like page number okay, so you flip to the back, okay, then you start to see all this like lithium, sodium, and stuff. So you're gonna flip it to the back because what I planning to do is I'm actually trying to do Form 4 Chapter 6. So Form 4 Chapter 6, it's your acid, base, and salt. So mostly it's at page number 69. This one. Okay, so look for page number 69. Okay, you see a spatula, okay, adding into a beaker of acid. So that is what you're looking for now. Okay, got Okay, so guys, so today, these 2 hours, what I plan to revise is your Form 4, Chapter 6. So we know that Chapter 6 is actually your acid, base, and salt. So I will try to do questions based on your exercise revision pack right here. And then in the meantime, so if you have any question, you just ask in the group chat. Okay, and then what I can do is I try to revise whatever that you are not sure on this chapter lah. Okay, so what we can see inside here is, so on page number 69, okay, we have this diagram right here. We have excess calcium carbonate adding into your 100 cm cube 1.0 mole per cube nitric acid. And the reaction, they say it forms solution S, gas U, and water. So to predict what is S and U, so this is the product. So to get your product, the first thing and the only way to get is actually to write out your chemical equation. So the first thing that comes to your mind, calcium carbonate is what symbol? So calcium carbonate is CaCO3, and then plus what? Nitric acid. And so what is your nitric acid? So nitric acid there is actually your HNO3. So guys, all these symbols are not provided in exam. You have to actually write out yourself. Okay, so from here, what you're going to do is, okay, so from the two reactants we can see from here, you can actually predict this thing coming out, where you take your Ca combined with your NO3, you get your CaNO3 bracket 2. Why is it so? Because your Ca is 2 plus, NO3 is minus. Okay, so you're going to get your CaNO3 bracket 2. And then your H and your CO3, these two things by right, they should combine. But because of this acidic property, so he will just corrode, where your H only take the O, you don't take the whole thing. Okay, so you have your H2O forming your H2O, H2O plus CO2. Okay, so guys, those who just came in, so your October notes, page number 69. Okay, you flip to the back, got the two page and one page, two page into one paper that exercise at the back, page number 69. For those who just came in. Okay, okay, so what we actually have now is we predicted the product form at the back. Okay, so what you're going to do now is you try to match to whatever is provided here lah. Okay, so lime water turn cloudy for carbon dioxide, correct. Okay, so but they never asked that here lah, so it's fine. Okay, yes, Yongyi, come. Yongyi, page number 69, your book at the back. Okay, page number 69. Okay, so to actually matches what you actually see from here, so we say water got idea, see. They say got water, so water here got, okay. Then they got solution S and gas U. So to match inside here is the only gas you can see, carbon dioxide gas is your gas U, and then this will be the solution S. So that will be the two information we can get from here. So the calcium nitrate is your solution S, and then your gas U is carbon dioxide. So they ask you the first thing, identify gas U, then describe a chemical test to determine the presence of N ion in solution S. So guys, I think the first mark, very simple. Gas U is your, based on equation, gas U is carbon dioxide. So guys, when they say identify, identify means name. Okay, don't give me CO2. Identify, always use the name of your chemical. So we say gas U, you say is carbon dioxide. Okay, that's one. And then this first mark settled already, okay? But what they want the next, I see, 5 marks total. So means actually got 4 more marks that you haven't scored. Then okay, they say then describe a chemical test to determine the presence of N ion. So what they want is detect N ion. So you have to first decide what is N ion. Okay. So N ion, channel CO2 into lime water. I know. Okay, that is a test for what? That's a test for carbon dioxide gas. But they are not asking you to test carbon dioxide gas. They are asking you to test the N ion. So what is N ion? N ion is actually your negative ion. So who is the negative ion in solution S? Okay, not the calcium carbonate. Okay, they want to actually test the negative ion in S. And who is S? So based on what we have said, S is CaNO3 2. And what you're going to do? you're gonna find out the ions inside. So we have Ca. So if you split them into ions, CaNO3, you get Ca2 plus. NO3 is minus. So technically, you are asking to test nitrate ion, NO3 minus. So how do we test nitrate? So guys, in your chapter 6, your acid, base, and salt, specifically salt. Salt got a specific topic called cation test and anion test. So cation means all the positive ion tests, and then anion got all the negative ion tests. So this one there fall under the negative ion test, and negative ion test, this is one of the hardest. Why this one very hard? Because this one, at the ultimate goal, the ultimate result for nitrate, you're supposed to achieve a brown ring form. Okay, so if you try to recall back, brown ring is what? Brown ring is where your test tube, your test tube, you see a brown color ring form on your chemical. So this result is to prove that you got nitrate ion. But to get into brown ring, you need to add a lot of stuff. You need to add many things just to get into brown ring. So that's why these 4 marks, the remaining 4 marks is all for your test for the nitrate ion. Okay, so guys, I bet you all forgot because now you're all studying for other subject, or maybe your chemistry still far away. You all never study yet. Okay, so technically, I will revise for you. So for here, we say test for nitrate ion. This one, test for nitrate, NO3 minus. So this one, number 1, always when you're testing for a certain negative ion or certain positive ion, your step 1 is to always add in the solution that you are having into a test tube first. So right now, the solution having this ion is a solution S. So we say add 2 cm cube. Guys, why 2 cm cube? Because for testing, you are using a test tube. So test tube, just put 2 cm cube. Will be good enough because test tube maximum is 10 cm cube. So you put 2 is like 20% of it. So add 2 cm cube of solution S, which is the solution right now, into a test tube. Okay, number 2, after your solution inside, what you're going to do is you have to add in some chemical to make into brown ring. How to add, what are the chemical to add in to get you a brown ring? So we're going to actually add 2 cm cube of dilute sulfuric acid. Guys, this is the first but not the last. Why? You have to say follow by, means you add in acid first, and you follow by 2 cm cube of iron 2 sulfate solution into the same test tube and shake well. Okay, make sure you have the word shake well. So shake already. You see brown ring? No, not yet. Got one more. So in total, you add 3 chemicals. You add 3 chemicals in total. So after adding 2 chemicals right here, you add few drops of concentrated sulfuric acid into the slanted test tube. Okay, better word guys. I changed the word into down the slanted test tube. Okay, down means you what you do is you imagine you have a slanted test tube, and then you add in your acid drop by drop. Okay, so like it flow down from the side of the wall. Okay, so you say down the slanted test tube and do not shake. Okay, then guys, these are all the steps for getting a brown ring. Okay, so those who just came in, page number 69 in your October notes exercise at the back. Okay, still got people coming in. Page number 69, your October notes, page number 69, at the back exercise, okay? Hi Cheng Yu, hello. Hey, finally see your brother that day on Sunday. Okay, so back to here guys. Yeah, after adding all these chemical, how do you get as a result? So after adding all this, brown ring form confirms the presence of nitrate ion. Guys, this is your 4 mark. Okay, so this is 1 mark for gas carbon dioxide, and this 4 mark is for your test for nitrate. Okay, guys, so hopefully you all can actually recall this, okay, but I don't think you all can recall in very detail, so try to write a few times, so to make sure that you can actually write this out. And because we got more tests, right? We got tests for carbonate, okay, we got tests for nitrate, we got tests for chloride, we got tests for sulfate. So we got multiple tests for different negative ions. So make sure you know the tests for the negative ion. Okay. Okay, teacher, this one got a chance to come out for structure. Structure usually don't come out this one. This one usually come out in essay. Okay, moving down. Write a balanced chemical equation and calculate the volume of gas, you guys. So chemical equation we done already. So we write down here one more time. So calcium carbonate. Guys, those who just came in again, page number 69 on the exercise on October notes. Flip to the back. So calcium carbonate plus nitric acid. We swap your partner, become calcium nitrate, CaNO3 bracket 2, plus water and carbon dioxide. Then you're going to do what? Guys, one thing. You have to balance equation. They say write a balanced equation. So always check after you write out your chemical equation. So from here, so if you balance it off, you're going to get something like this, 2HNO3. Then, okay, nothing special here, 2HNO3. Okay, so equation still okay. And then calculate the volume of gas U. So where is gas U? Gas U is actually the carbon dioxide gas. So you're looking for the volume. Okay, guys, I cover up the calculation one time in detail. Later on, if I got more calculation, I just gonna go through very fast. Okay, I don't want to spend a lot of time on calculation. Okay, so on the idea here is to get your volume of carbon dioxide gas, you're going to find something else that they give you in terms of numbers, which is some hint they give you by maybe they give you mass, or maybe they give you concentration, maybe they give you volume. So always to do your calculation, you always look for two things: what you are provided and what you are looking for. So I'm looking for volume of gas U, which is carbon dioxide gas. But what am I provided in exam? If you read the diagram, read the question, you realize that there is provided with 100 cm cube and 1 mole per dm cube, your nitric acid. So these are the three information. That's why from here, I can label down my nitric acid. Its molarity 1.0, volume is 100. Okay, so based on these things, guys. So basically, the mole per dm cube is called molarity. We call it concentration, but in a specific term, we call it molarity. So with this information, I think your step one, you're very familiar with this. With M and V, I can use number of mole equals to MV over 1000. Okay, but be more specific. This is number of mole of nitric acid. So I write down HNO3. So the molarity is 1, volume is 100. So you put it and press the calculator, you get 0.1 mole. Okay, so this one okay, can Okay, those who just came in, page number 69 on your October notes at the back. Okay, the revision pack included in your October notes at the back. Page number 69. Okay, let me bring down this page number. Okay, then after having your acid number of mole, what you have is now I got number of mole for nitric acid, but I want the volume for carbon dioxide. So to actually relate from one chemical to another chemical, you always need a step 2, where this step 2 do this thing called a ratio. What do you do in ratio? You compare the number in front of your equation between the chemical that you have, which is now is HNO3, compared to the chemical that you want, which is carbon dioxide, CO2. Okay, so you compare what you have and you compare what you want. Then I'm gonna having your what is the big number in front of HNO3? You see a 2 there, so that's 2 mole. Then your carbon dioxide is no number, so no number here. So no number means 1 mole. So the ratio based on equation is 2 mole of acid to produce 1 mole of carbon dioxide. That is based on equation. But based on true number, based on actual number, so what's actual number? Then the 0.1. So 0.1 mole can produce how many mole of carbon dioxide? Okay, so you're gonna follow the ratio law. So 2 to 1 is divide 2 ma. Then 0.1 divide 2, you're gonna get 0.05 mole. Okay, so this is number of mole of carbon dioxide gas. Okay, so with this number of mole of carbon dioxide gas, how do you find volume? So guys, so if you think about the same formula, mv over 1000, it sounds okay, but it actually is not applicable. Why this one cannot use? Because carbon dioxide, do you have m provided? Do you have your molarity provided? Don't have. So it's not suitable to use mv over 1000. Instead, we have another formula with volume. What is another formula with volume? We have V over mv. Volume over molar volume, which is what? Which is molar volume is given by the question 24 dm cube mole per dm, 24 dm cube per mole. That is your molar volume. So this molar volume 24, number of moles 0.05. Then your volume of carbon dioxide is 0.05 multiply 24. Okay, so I believe this one you all do the maths. A times 5. Okay, so you get 1.2 dm cube. Correct? Correct? 1.2. Okay. Can okay. Teacher, need to write equation if question didn't say balance equation. Okay, means what? If they never mention this, they ask you to calculate only. Do you need to write equation? Or do you mean to balance it? Of course, of course. Equation always have to balance it. Never leave your equation unbalanced. Make sure when you write equation, always balance it. Okay, can okay, so now, so done with calculation, done with one of the negative ion tests. Okay, then teacher, how to know it's NHNO3 is the one that produce CO2 and not CaCO3? Okay, the question is, you mean the ratio, is it? Why I compare HNO3 to CO2? The simple concept is actually doesn't matter. Because everything in the equation, they are always in ratio. Means I can also ratio from this to this. I can ratio from this to this. I can ratio from water to carbon dioxide, also can one. But the issue is, what is the information provided? So that's why I say, when you're doing ratio, you always ratio on what you have, which is right now is the acid, compared to what you want. That's all you need to know. Okay, it doesn't matter who compared to who one, but it matters on who got number. Okay, if you say, teacher, can I compare CaCO3 to CO2? Actually can, but you don't have information for CaCO3. That's why you can do ratio for CaCO3 to CO2. Okay, you get the idea? Can so actually ratio everyone works one. Who to who also okay one. Just that you need numbers. Okay, you need to have numbers. So use the one that provided with information, correct? So you compare what you have and what you want. That's all you need. The rest not provided, so just ignore. Okay, can all good, okay. So moving down. Okay, those who just came in, okay. So early morning cannot wake up, page number 69, guys. Okay, October notes, October notes, page number 69 is actually at the back of the revision pack of your October notes. Okay, October notes is chapter 8, but at the back of revision pack, you look at page number 69. Okay, then going down. In another experiment, Raju is mixing two different aqueous solutions to prepare barium sulfate salt. Right? One thing that you can see from here, prepare salt. The moment you see prepare salt, you're definitely do one thing. You're gonna flip. Next question. You're gonna give up, right? But to prepare salt, why is it so many people giving out on this topic? Because prepare salt need to revise, need to recall a lot of stuff. For example, guys, before you prepare salt, you must understand what salt is soluble, what salt is insoluble. Okay. For those who actually teacher, why Hui-san and Celine don't come? You ask them. why they don't come? How I know? They confirm cannot wake up. Yeah. Okay. You text them. Okay, make them come. Okay. Okay, so on the idea here is if you want to prepare a salt, what you have to do is you have to actually recall solubility of salt. who is soluble, who is insoluble. That is very important before you start your salt preparation. So guys, if you have your notes with you, okay, because many of you actually under my normal class one, okay, so what you can do is you can refer back to your Form 4 chapter 6, okay, but maybe it will take you some time to find, but never mind, I give you the notes right here, let me show you, in your, let me show you, okay, in your Form 4 chapter 6, right, what you see is this one. Okay, you have something like this. Okay, if you remember, where we actually have something like this. Okay, very good. Okay, someone said, teacher, barium sulfate is insoluble, right? Very good, correct. Okay, so if you remember it clearly, okay, it goes in this way. So we have salt, we have ions that is confirmed soluble. We have ions that are confirmed insoluble, except with SPA. We have ions that sometimes soluble, sometimes insoluble. That's how the idea works from here. Means anything with Cl or SO4 is always soluble or soluble, except when he combine with these three combination. Okay, means this six is insoluble. Okay, this red color six one this six red color one is actually insoluble. Okay, so right now the question want me to produce barium sulfate, BaSO4, which is match exactly the same here. Okay, BaSO4, correct. Yes, to memorize guys, if you remember, to memorize this Cl, I say is Persatuan Agama Hindu. So then for SO4, we got Persatuan Bahasa Cina. Okay, so we can use some Indian food and Chinese food to memorize. No? Okay, we got Roti Canai, Persatuan Agama Hindu. We got Siu Pao, that is Persatuan Bahasa Cina. Okay, so make sure you can recognize in this way, because right now, if you want to produce BaSO4, guys, it's under insoluble category, right? Why? Because once you decided what category, you will need to decide what method to use. So if you are trying to produce and prepare a soluble salt with SPA, what is SPA, guys? SPA is sodium, potassium, ammonium. With these three, you're gonna use neutralization titration method. But right now it's not BaSO4 is not even a soluble salt, so method one out. Then number two is also for soluble salt, but it's for non-SPA. So non-SPA is what? So non-SPA is your no sodium, no potassium, no ammonium, but also a soluble salt. So the problem is what? BaSO4 is insoluble. So method one out, method two also out, because this two is to produce soluble salt. So if you want to produce insoluble salt, I need to refer to the last category, method 3. We're going to go for double decomposition reaction, or we call it the precipitation method. But what is the trend? What is the requirement to feed to get you this double decomposition? So guys, if you remember, or even if you forgot, let me revise for you. The requirement to do double decomposition must be soluble salt matched with soluble salt. Then you swap your partners, you swap your ions, become insoluble salt with another side product, soluble salt. That is the trend that you have to use in terms of double decomposition. It means if I give you the idea, see, if I want to form PbSO4, which is an insoluble salt, what is the chemical that I need to predict to use on the front, okay, as your reactant to get you PbSO4? So the idea is I must always break your PbSO4 into half. Okay, I break this into half. Then one side got Pb, one side got SO4. Why like that? Because later on, I want my chemical to swap partners. So you are doing a reverse analysis. You are doing a reverse concept to actually predict who is in the front, so that later on they can swap their partners, become PbSO4. Okay, so now I break them into half first. One chemical got Pb, the other chemical got SO4. But the problem is what? Pb cannot just be Pb. SO4 cannot just be SO4. They are ions. This is Pb2 plus. This is SO4 2 minus. I need to match a negative ion to your Pb2 plus. I need to match a positive ion to the SO4 2 minus. So the problem is what? This Na, this NO3, is it any ion? Is it any negative ion or any positive ion? So cannot. Why? Because on this idea, must fulfill the requirement of soluble salt mixed with soluble salt. If you go and say, teacher, can I go with PbCl2? Cannot. Why? Because PbCl2 is insoluble. Because if you don't use this soluble plus soluble concept, you will get error later on. So you must fit the requirement of soluble salt plus soluble salt. So I match with NO3 because of what? Because nitrate can guarantee soluble. Remember nitrate, the SPAN? Nitrate can guarantee my soluble salt. Then why SO4 mixed with Na? Again, Na guarantee my soluble salt. You understand? So the best way and the easiest way and the fastest way is to mix your PB and SO4. You mix them with SPAN salt. You mix them with your spun salt, spun ions. You mix them together, then they confirm we can be soluble salt and soluble salt. So soluble salt and soluble salt, swap the partners, you get insoluble salt with another soluble salt. So this is the idea of double decomposition. Let's apply to my question right now. What is my question? My question want me to form PaSO4. If you want to form PaSO4, they're gonna ask you, suggest or predict the chemical in the front. So what you're gonna do? What will be the chemical in the front? Break them into half. One side with Ba, one side with SO4, and then match your Ba with NO3, match your SO4 with Na, K, or ammonium. Okay, so means that my answer here can be K, your BaNO3 bracket 2, and then this one can be K2SO4. Okay, now. Okay, wait. Someone's trying to come in. Sorry. Okay, so soluble salt plus soluble salt. Make sure you understand how this thing works. BaNO3 2 with K2SO4. Okay, guys. So back to the question that we see just now. Back to the question. Wait. Why my iPad become black? Okay, so this one. So you see, suggest your X and Y, which is the two chemicals that you pour together to form your barium sulfate salt. So this is what you are actually looking for. X and Y pour together can prepare barium sulfate. Who are X and Y? Is what we say just now, based on the equation that we memorize. Not memorize, that we analyze. So guys, do we need to write equation here? They never ask you to write any balance equation, so equation is not needed. Okay, but the problem is you need the equation to guide you, okay. So I give you the idea lah. So in order to form BaSO4, I need to have something Ba, okay, Ba something with SO4 something, okay. Later on, the swap partners become BaSO4 so I will mix with BaNO3 bracket 2 and K2SO4. Then when you swap the partners, you get a side product, KNO3. Not important because this one is soluble salt. It's a solution later on. You can actually filter out your BaSO4. So means from here, guys, what is X? We can write barium nitrate solution. What is your Y? Is potassium sulfate solution. Okay, guys, 2 mark. Guys, just to get 2 mark, you have to recall solubility and you have to recall the method to be used to produce precipitate. The method to be used to produce insoluble salt. These 2 mark very hard to score. But of course, if you're familiar with the flowchart, you can get the answer very fast. The problem is if you cannot recall the flowchart, you're gonna burn your brain cell. Okay, so this one kind of one of the hardest thing you have in your syllabus. Okay, then X and Y. Can I change potassium to another soluble salt? Can. You can change it to sodium sulfate. Okay. And then ammonium sulfate also can. As long as a soluble sulfate salt, it's fine. Okay, can. Okay, so after this, after the precipitate is formed, describe how Raju can get dry barium sulfate salt. Guys, how you get the dry salt? So dry salt is like you have your liquid chemical, inside got a solid chemical. Like your water inside got sand. How would you want to actually collect your dry salt? So usually what we can say is very good. Someone say the full marks. The full name is what? HCFRD. Okay, guys, this 5 steps is called heat, cool, filter, rinse, and dry. Yeah, usually I call it the what? The hippo can fly, really dangerous. Correct. But here, no need to use everything. You know why? Because heat and cool is meant for what? Heat and cool is meant to heat the water away and to make your soluble salt become a crystal form. Which is right here, no need. Why? Because your precipitate, your final product, this guy is already a solid, right? Do you need to heat and cool to make it a crystal? No need. It's memang a crystal by nature. So that's why from here, you no need to heat and cool. You just go with filter, rinse, and dry. Okay. So the heat and cool for what? For collecting soluble salt that dissolve in water, which is method 1, method 2, need to do heat, cool, filter, rinse, and dry. Method 3, no need to heat and cool, just filter, rinse, and dry. So for my answer here is filter the crystals, the salt crystal, filter the salt crystals, rinse it with a little distilled water, and dry by pressing between filter paper. Okay, nice. This one, okay, can do, understand, Can write rinse the salt with distilled water. Rinse the salt with distilled water. Can. But try to always record the word a little. Because this one very important. Okay, not very important in here, but it's important in the method 1, method 2. Because method 1, method 2, you are actually collecting a soluble salt. So if you rinse with water, you must only rinse with a little distilled water. So I rather you memorize the word a little distilled water for every method. Method 1, 2, 3, all can use. Okay, because if you don't use it in method 1, 2, might be wrong for this sentence. Okay, can Okay, so guys, listen. Okay, next page will be page number 70. Page number 70. Okay, it's the same question, but continue on the next topic lah. So we have a concentration provided 0.0001, okay, with all the different concentration, with the pH value given of hydrochloric acid. So guys, based on this table, state the relationship between the concentration of acid with their pH value and state the type of acid. So guys, number 1, what is the relationship? Whenever you see the concentration getting bigger, what happened to your pH? Higher or lower? So on the relationship, correct? You can see the word. So the higher the concentration, the lower the pH value. Okay, so use the word higher or lower. Higher pH. Wait. Okay, you see, bigger concentration, smaller pH. Okay, so this one here, guys, on a simple sentence, on a simple sentence, we say, the higher the concentration, of hydrochloric acid, the lower the pH value. Okay, 1 mark. Nothing much here. Okay, but what is the type of acid, of hydrochloric acid? So talking about type, what word should we use right here? I think half of the class are gonna say, oh, teacher, is strong or weak? Then some of you, I say some of you say, teacher, this one is monoprotic. So the question is, should I write strong or should I write mono? Because these two is considered type, right? So type of acid, guys, type of acid, always we always use strong or weak. Strong or weak. Did you? I thought monoprotic acid also okay, right? Because this only got one H HCl is only got one H plus, so it's a monoprotic acid, right? Correct, guys. But when they say type, you say strong or weak. Then when do you use the monoprotic diprotic? When they say basicity. So guys, so this word you all always don't remember one again. So commonly forgot by student. Whenever they say type of acid, this one type of acid, we got strong and weak, strong or weak. Can But if you want to use the word monoprotic, diprotic, or triprotic, that is called the basicity. Basicity of acid. Then we got monoprotic, diprotic, and triprotic. Okay, make sure you know the difference. When they say type of acid, you use strong or weak. Unless they say basicity of acid, then you say monoprotic, diprotic, or triprotic. Okay? Basicity is not for base, it's basicity of acid. So basicity is the number of H plus you have in your acid. So type is always about strong and weak. All good? Okay, just to do a recap. What are the acids in our syllabus that is strong and that's weak? So if you don't remember, write down. Okay, who is strong acid? We have three types of strong acid in our syllabus. We got HCl, HNO3, and H2SO4. Then weak acid, weak acid got H3PO4. This one is called phosphoric acid. And then we got the other one, very long symbol, it's called ethanoic acid. This is your vinegar in daily life. CH3COH. Okay. Ammonia is weak. Yes, ammonia is weak, but weak alkali. Not here. This one is acid. Ethanol, no. Ethanol is alcohol. Ethanoic acid. Okay. See, a lot of people don't recall this one. That is called phosphoric acid. This one is called ethanoic acid. Okay, can so these are the need to memorize the chemistry card. Yes, like I give you the card not for fun one okay, it's really gonna be helping you in exam one. Okay, so after you can split your acid into this strong and weak, you can also split these five. It means in your syllabus, in the simple understanding, you only learn 5 acids. Okay, these are the 5 acids in your syllabus. You can also categorize them based on basicity of acid. So who are monoprotic? Monoprotic is HCl, HNO3, and one thing that you never gonna realize is ethanoic acid is also monoprotic acid. How did you? One H for HCl okay lah, one H for HNO3 okay lah, but ethanoic acid got so many H why also monoprotic? Because ethanoic acid, the H plus is at the back. Then this whole thing in the front is one negative ion, which is this H is not a positive charge. This H is a covalent bond. So this acid very special. This acid inside got covalent bond and also got ionic bond. Ethanoic acid got big part covalent, got small part ionic. That is a special thing about ethanoic acid. So don't think you see, the more the H you see, this one is like, teacher, is this like tetraprotic acid? Got 4H. No. Okay, it's still under monoprotic. So it's only under 1H plus. Okay. I thought ionic only for metal. Ionic is metal and non-metal, but also got H plus remember not? This is the only case where you have your positive ion for non-metal. We got one non-metal positive ion, H plus. Okay. That's why it's weak this one here. That's why you see this covalent mixed with ionic. This is a weak acid, not a very strong acid. Okay. So this is monoprotic. So CH3CO, no. Means this is the positive ion. Usually metal is positive ion, remember not? Let's say Na and Cl is plus and minus. So the plus is the metal. But we got one exceptional case that this guy is non-metal, but can also become positive ion, is the H plus. So no metal here. No metal here. This is a case where no need metal also can form ionic compound. Okay, then you see even HCl also like that. H plus Cl minus, where got metal? Where got metal? Don't have one. Okay, so H plus is the only ion that is positive charge but non-metal. Okay, so OH also got ionic bond. Got. OH, let's say if I got like NaOH, this one is plus and minus. Like that. So only for this one, but H plus is the only positive ion is non-metal. Others is metal one, like Na plus, Mg2 plus, Al3 plus. Okay, so H plus is the only positive ion that is non-metal. HCl also ionic, of course. All acid is ionic. That's why they are ionized in water to produce H plus. That's the definition for acid. Okay. Can I? Okay, so moving on. Diprotic only got one, H2SO4. Triprotic only got one, is the H3PO4. So these are the categorized thing we can do in your acid for this case. But for your alkaline, guys, alkaline nothing much lah. Your alkaline only got strong and weak. Okay, so who is a strong acid? Strong alkaline. Strong alkaline then got NaOH and KOH. So sodium hydroxide, potassium hydroxide. Alkaline weak only got one, is ammonia, NH3. So you see, alkaline only got three, very easy one. But acid got five, and these five can strong and weak can also got monoprotic, diprotic, triprotic. Alkaline don't have monoprotic, diprotic, triprotic one. Okay, alkaline just strong and weak. That's all. Okay, can so guys, so with this, okay, no wonder they like to ask acid more. That's why acid got more thing to ask. Okay, so from here you can see hydrochloric acid is a strong acid. Okay. Okay, moving on. Calculate pH, guys. Anyone remember? There is a formula for calculation for pH value. Yes, the negative log, correct. So if you remember, the formula for pH is equals to negative log concentration of H plus, which is given by the question usually. Okay, so you see, calculate pH value of sulfuric acid with a concentration of 0.1 mole dm negative 3. Guys, so seems like I just put in 0.1 here, right? So negative log 0.1, settled. But guys, if you do that, you actually don't get marks. You know why? Teacher, I thought you just put in concentration will do, right? But one problem. pH value, the concentration have to see monoprotic, diprotic, triprotic, which is your sulfuric acid is H2SO4. It means every concentration of acid give you 2H plus. It means what? Your 0.1 plus times 2. Okay, can so this is the trap that you might fall into exam if they ask you to calculate pH. But if you calculate for hydrochloric acid, very simple one, just negative log is 0.1. No need to times 2. Yes, okay, you get the idea. Uh, so this is a trap that you confirm for. Now you know. I give you the antivirus. Okay, can make sure you don't fall into this. Okay, so now you have a 0.1 multiply 2 because of diprotic acid. So diprotic acid you put in. So what do you get? Guys, early morning calculator not beside you. Go get. Hey, come. Get me negative log 0.2. I know my math very good lah, but my brain cannot do log. Okay, one decimal place, guys. pH value is one decimal place. One decimal place will do. So you're gonna get 0.7. Okay, 0.7. Can guys, 1 mark. Then compare your pH value with the hydrochloric acid given by the table. Okay, now. So if you check, 0.1 is pH 1. Now your sulfuric acid 0.1 is pH 0.7. So is it higher or lower? It seems like sulfuric acid is lower than your hydrochloric acid. So guys, 1 mark you. What you say? You say pH value of sulfuric acid is lower than pH value of hydrochloric acid. Okay. So 1 mark. Then 2 more marks how to get your explanation. Okay. Because it ionizes in water to produce more hydrogen. Okay, this term is to explain strong and weak. If you want to say ionize completely, ionize partially to give you high concentration or low concentration of H+, that is about strong or weak. But here, it's not about strong or weak because both are strong. Sulfuric acid is strong. HCl is also strong. So writing out ionized completely here don't get you any marks. So what is the difference between your sulfuric acid and hydrochloric acid? Is the other category, the basicity of acid. Okay. So that is how you're gonna explain in exam, okay? So make sure when you do comparison, if both strong, don't use the word, don't mention the strong definition, okay? Mention about the diprotic and monoprotic. Okay, you get the idea here, so what is the full answer here? So we say H2SO4 is a diprotic acid. And what is the definition for diprotic acid? Not bad, not bad. Okay, somebody give me the definition for diprotic acid. That ionizes in water to produce 2 hydrogen ion, 2H plus, per acid molecule. Forget it. See, this is the definition for diprotic acid. Then how about monoprotic? Same sentence, just change the 2, become 1. Okay, so HCl is a monoprotic acid that ionizes in the water to produce what? 1 hydrogen ion per acid molecule. Okay, it means that H2SO4 give you more H plus per acid molecule. So in the conclusion, we say hence, the higher the concentration of H plus, the higher the concentration of H plus, which is the hydrogen ion, the lower the pH value. Okay, so if different basicity, write strong acid. If different basicity, write monoprotic, diprotic. If different strength of acid, then you write strong and weak. Because you see H2SO4 and HCl both under the same strength, strong HCl strong, H2SO4 also strong. So cannot use the wording for strong. But they are under monoprotic and diprotic. So get the difference in their the trend from here, then you have to use the correct trend, correct category to explain. Teacher, so the explanation of mono and diprotic is 2 marks. Or you mean how many marks here in total? Actually, guys, the marks here is more than 4 marks. I give you answer more than 4 marks already. So actually the 4 marks is at this. 1 mark here, 1 mark here. You say diprotic acid, 1 mark. Monoprotic acid, 1 mark. And then concentration is 1 mark. This one is 5 marks already. So this answer here I give you is more than 4 marks. Okay, more than you need. But to be safe, to be safe. Okay, teacher, why this question write about basicity? Because HCl and H2SO4 is under the same strong acid. That's why we use monoprotic, you see, HCl, H2SO4 under different basicity. Okay, so the reason why they got different pH, you're gonna look for the different category. So if they fall under the same strong, you cannot explain why pH different. You must find something that is different to explain the pH different. So monoprotic, diprotic is the difference between them. Okay, can all good Okay, teacher, will exam ask us to compare HNO3 and HCl? Okay, if exam asks you to compare HNO3 and HCl, you're supposed to expect to see what? Same pH value. Why? Same strong acid, same monoprotic acid. So every concentration get you the same amount of H plus, so it will be the same. Okay, so it's possible to ask to compare strong monoprotic acid. Both strong monoprotic acid, but your expectation should be same pH value lah. That's the idea of it. Okay, can so if one strong, one weak, just talk about the definition of weak and strong acid. Yeah, correct. Correct. Okay, so if they ask you to compare like HCl and ethanoic acid, then you know HCl ethanoic acid is what? Both monoprotic, so cannot use monoprotic, but they are one is strong, one is weak. Okay, you get the idea? Can so you make sure you know how to use the correct category. Sometimes we talk about strong and weak acid, sometimes we talk about the basicity of acid. Okay, based on different properties. Okay, so if you were to compare, as I said lah, HCl and H2SO4, I will prefer to use basicity. Okay, because they fall under different category. But if I were to compare HCl and ethanoic acid, I will use type of acid to explain because they fall under strong and weak category because same monoprotic. Okay, so you always try to select the correct type of acid to explain the difference. Okay, the category that you have to use correctly. Okay, so if this one okay, guys. Okay, again, moving on. Okay, moving on, going down, we have next one. Guys, I know our progress is not as fast as you think, okay? But because I try to revise more details, okay? So on the next one, we have your H2X, HY, and HZ. Different pH value, and they are all the same concentration again. So this is, guys, all this is typo, all this ADD is acid, all this ADD is acid. Okay, we use AI to scan, the AI a bit blind. Okay, so now on the idea here, you see, they say got three type of acid, diprotic, and then these two are monoprotic, your HY and HZ is monoprotic, suggest your H2X, HY, and HZ. So guys, I want the name of these three acids. I think the first one very easy. Got H2. Confirm is who? H2SO4. Very good. H2SO4. Now guys, please, in exam, maybe you all can lazy to type up the name right now, but they want the name. Don't write H2SO4 if they're looking for name, okay? Please be careful. So from here, we say H2X is sulfuric acid. This one, a lot of careless mistakes. A lot of students, they know the answer, but they go and write symbol. Okay, so please don't fall into all this trap in exam. Okay, so now H2X first mark very easy, but H2Y and HY and HZ, they are both monoprotic but different pH. So guys, if they both are monoprotic, what is the other reason to get you different pH value? It's about your strong and weak acid. Yes, the strength of acid, okay? Because since they are having the same H plus monoprotic, then the only difference right now is the strength of acid. So who is strong, who is weak? 2.0 or 5.0? Very good. The 2.0 is strong. Okay, so 2.0, this is strong. And then the 5.0 is weak. Okay. So based on this, now we say already, okay. Ui, Joey, so many times your pH value wrong already, you make sure you be careful, okay. Since someone's still confused about the strong and weak, okay, I give you the usual way I identify, okay, so in this way, okay, we have your pH value. We know pH, neutral is 7, so from 0 to 6 is acid. Then to from 8 to 13 is alkaline. Correct or not? So, but how I remember who is strong, who is weak? Numbers that are near to 7, which is this is weak. Like 6, 8, as long you are near to 7, is weak. Then numbers that are far from 7, this is strong. Okay, so you make sure to check your weak and strong. 8 to 14. Why is it 13? Sorry guys. I also early morning not wake up. Okay. Okay, so see, so near to 7 is weak. Okay, then far from 7 is strong. So this is the way I usually try to recall in exam myself. Okay, so now from here, since we say 2.0, so 2.0 is here lah, so it's strong. Then 5.0 is near to 7, this is weak lah. Okay, now, so this one 2.0 strong, 5.0 is weak. Okay, who is a strong? Monoprotic acid. So I believe just now got a lot of people give me answer already. So for HY can be hydrochloric acid, but is that the only answer? No, you got one more. Nitric acid also can. Yes. Okay. So HCl or HNO3. Okay. Can Then hydrogen chlorine cannot. Must write hydrochloric acid. Okay. Then we have HZ. HZ there is a weak monoprotic, guys. In our weak monoprotic, we only got one. Ethanoic acid. Okay. 3 mark. Settle. Now guys, explain the pH of HY and HZ. Why the pH different? So guys, now you tell me. Do we use strong or weak to explain or monoprotic, diprotic to explain? For this last 3 mark, you compare HY and HZ. Both monoprotic, right? See, Chengyu? Okay, guys. If both monoprotic, we do what? We use. Oh, you thought compare H2X and HY? Okay. So both are monoprotic. Don't talk about monoprotic. Talk about strength. Okay. Talk about your strong or weak. I see. Still got a few of you say you explain using monoprotic because I think you all see the wrong one. Okay. They want to compare HY and HZ, not H2X and HY. If you compare H2X and HY, it's about mono and di. But now it's HY and HZ. It's not about mono and di. It's about strong or weak. Yes, okay. So now, guys, so what do we say? So we say HY is a strong acid. So guys, we're gonna use your definition of strong acid that ionizes completely. So guys, we put in some keywords for strong acid in water to produce high concentration of H plus. Okay, then HZ is a weak acid that ionizes partially in water to produce low concentration of H plus. So conclusion will be what? Conclusion is the higher concentration of H plus, the lower the pH value. Okay, guys, this one okay settle Okay, if this one okay, moving down. Okay, this one is something slightly different because you see they say in another experiment, you have your HY acid needed to neutralize your sodium hydroxide. So guys, what is this? This is not just about acid, not just about alkali, it's neutralized. So it's under neutralization. Okay, and write the chemical equation. So we got acid HY. What is HY? Don't know, but we know it's HY. So HY plus, what is the other alkali? Sodium hydroxide. So what is sodium hydroxide? NaOH. Then what you gonna do? You're gonna do swap your partners. So guys, wanna give you a guess? Wanna give it a try? On what are you gonna form? Swap partners ma? Correct not? NaY, very good. Someone say NaY. Why? Why leh? Because Hy, H is plus ma. Then Y is the negative ion, no? Correct not? So the Na with the new negative ion will be the NaY. Find new girlfriend ma. Okay, you swap the partners, okay? So you're gonna get NaY and the H and OH becomes your water. Very good. Okay. Is this a balanced equation? Check guys. Always have to check. Don't say, sure, okay lah, they never ask me to balance, okay? I don't know the balance. Okay. Check. Okay. Always must check your balance equation. So if you check your left and right, this is already balanced. Okay. Teacher, can I ask why I can't use hydrochloric acid for HY? Okay, if you stated hydrochloric acid on the previous question, you can use HCl. You can use HCl for this question. But imagine if the question never give this, you never do anything like this, you never list out the name of the acid, you cannot use that specific formula. You understand? Yeah, so you are only allowed to use if you are having question asking you the name of it or the symbol of it. Okay? Means in the previous question, they already mentioned, oh, HY is what? HZ is what? Then you can say HY right now. You can use HCl instead of HY. You can get NaCl instead of NaY. Okay. But can also write unknown, correct? Unknown also okay. Unknown is actually the best answer. Okay. Because why? Because I scared later your HY you put wrong acid. Later your HY you go and put ethanol acid. Jialat. Okay, then hard to do now, cannot. So having unknown in your question, always remain unknown is the safest answer. Okay, but unless you're very confident on, okay, I know HY confirm HCl. Okay, so correct. Okay, so using unknown is for safety purposes. Okay, not to say I don't know HY is HCl. I know, but HY safer. Okay, because maybe you're not sure in exam, maybe your confidence got damaged. Okay, so using symbol right here is better. Okay, using unknown. Okay, now, so since this is a correct equation, 1 mark, and there's already balanced, calculate concentration. Guys, we are looking for concentration of sodium hydroxide. Guys, do you remember what is the symbol for concentration in your number of mole formula? Is the molarity, right? Means you are looking for molarity of sodium hydroxide. So guys, what you're going to do, you have volume, molarity of acid, you have volume of alkaline, you have to find volume, molarity of alkaline, right? So by right, you can do MV over 1000 and then do ratio, okay, basically you do the normal stoichiometry calculation. Number of mole, ratio, number of mole. Okay, this is a 3-step stoichiometry, right? But the moment you see neutralize, this word can give you a shortcut formula. You actually learn, I teach you before, in neutralization, we have a shortcut formula. M1V1 equals to M2V2. No, that one is dilution formula. The equal, the 1 equal to 2, that one is before add water and after add water. So it's not about acid add alkaline. So it's about something add water. That one is called dilution. But if you are now acid over acid and base, is actually the other one. No, 14 minus, no, that one calculate pH. So for neutralization, specific shortcut formula is called MA/VA over MB, VB equals to A over B. Guys, actually this formula is just compiling your MV over 1000 ratio and MV over 1000 into one step. Okay, it means the 3 steps calculation, your MV over 1000 ratio and then MV over 1000, you combine everything into this formula. So this one only for neutralization. Don't use it in other calculation. This formula only meant for neutralization. Okay, neutralization only. Okay. So why this formula can be used directly? Because do you see I got labeled A and B. What is A and B? A stands for acid. B stands for base. So technically, you actually have your what? Yeah, so 25 cm cube is volume. 1 mole per dm cube is your molarity. But this two is for who? The 25 HY acid 1.0 mole per day cube. These are for acid, right? I label VA, MA. Volume of acid, molarity of acid. Then, to neutralize 25 cm cube of your alkali, this is volume of base. Because alkali under base, remember? Then calculate concentration of sodium hydroxide, means you're looking for molarity of base, MB. So guys, if you were to put in all the numbers that you see from here, VA 25, VB 25, MA is also 1.0, MB is something you're looking for, right? So leave your MB as unknown. Okay? But what is equal to A over B? What is A over B? This is actually your ratio. Okay, this is actually your ratio. What ratio? The ratio between your acid and alkaline based on the balance equation. So now, you tell me, any number in front of HY? No. Means 1. Any number in front of NaOH? Also no. Also 1. So means your final thing you can see is 1.0 times 25 divide MB times 25 equals to 1 over 1. So guys, can you find MB? Yeah, okay. Can I cut the 25? Come, guys, it's maths. You can cut whatever is the same. So if you do the maths, you should get 1.0 mole per dm cube. Is this okay? All good, Can, Understand, but guys, as I said, must put decimal. Yes, must put decimal. 1.0, the 0.0 must put. Okay, can? Okay, so this formula, as I said, is only for neutralization. So beware on this part. Okay, don't every calculation also go and use this formula. Make sure this only be used in neutralization. Okay, so this is under your neutralization. Okay, all calculation final answer is 1 decimal place. Okay, usually decimal place you follow the decimal place of the question. It means you see question here got 1.0, right? Your final answer must be also 0.0, 1 decimal place. If you see any numbers in your question got 2 decimal place, then your final answer must be 2 decimal place. Okay, so decimal place follow the decimal place of the number of the question. All good? Okay, going down. The sting of jellyfish is alkaline and causes pain. Suggest one substance that can be applied to skin to relieve pain without causing further injury. Give 3 reasons for your suggestion. Ammonia, ammonia is alkaline. And now the sting is alkaline. Alkaline plus alkaline, you get more alkaline. You now get more pain. Okay. So what your idea is, you have something that is alkaline causing pain right now. We're supposed to use the opposite to actually neutralize it. Coagulate. Okay, Colgate or you mean what? Your toothpaste Toothpaste also alkaline guys, you causing more pain. Put acid, very good, very good. Okay, some of you all give me a very good answer. Later I tell you what is the good answer. Put acid is not wrong. Put acid is correct, but it's not good enough. Well, why not good enough? Because this acid got very specific thing here to be very careful. You cannot put acid that is very strong. Why? Strong acid, yes, he can neutralize your alkaline, but he can also corrode your skin. So if you put strong acid, no pain because you got no hand. Okay. So don't use strong acid. Avoid strong acid. If you are having skin touching applied to skin, avoid using strong acid. So the best weak acid that you can get in daily life is what? Yes, a lot of people give me the answer, vinegar. Or you can just write ethanoic acid. Okay? And give 3 reasons. Why? So I see someone give me a very good answer. I think you gonna do before in school. Okay, so vinegar is what? It's a weak acid, number 1, correct. Okay, that's what you can do. Neutralize your alkaline sting. Okay now. So of course, so we can say Vinegar is a weak acid that able to neutralize alkaline sting. Okay, without causing skin irritation. Okay, so guys, how to get 4 marks? 1 mark for vinegar, 1 mark for weak acid, 1 mark for neutralize, 1 mark to avoid skin irritation. Neutralize and produce low concentration of hydrogen ion without corroding the skin. Okay. Neutralize got 1 mark. Low concentration of H plus. Okay. Consider weak acid, 1 mark. Without corroding the skin. Can accept. Okay. Got one more possible answer, guys. Because why use vinegar? This one is like common knowledge in daily life. It's cheap. Costs don't come into play. Because actually alkaline not very expensive also. Other alkaline also very cheap. The other acid, all acid alkaline, nothing is actually very expensive. Okay. So what happened is easy. Yeah, very good. Easily available. Yeah. So got one more possible answer is easily available. Okay, because you can get it in any restaurant around you. Okay, you can get it from your kitchen. Okay, easily access. So we say easily available. Yeah, I thought it's ammonia because I heard you are supposed to urinate on the sting. So it depends. Some sting is acidic, some sting is alkaline. So you cannot like really get sting. You just directly pee. Because the idea is you do not know what is the sting. Okay, what is the properties of the sting you are getting? So what you first thing have to do? Find doctor. Find doctor. Or you know what? Bring your litmus paper around you. Buy a litmus paper when you go to the beach. So when you're gonna sting it, litmus paper go in. Okay, you put the moist red litmus paper and moist blue litmus paper. Whoever change color, you know is what properties. Then you know what to apply. Try both. Like if you try both, the acid and the alkaline will neutralize. Your arm never neutralize. Okay, so like that. Okay, vinegar count as a substance? I mean yes. Take a bee and a sting, the same part. How you know? Don't know one okay. How you know the bee sting is acid alkaline? How you know that one is a bee or wasps? Don't know. So guys, the safest one is to go to see doctor. Okay, if you really get sting by jellyfish in real life, don't risk. Okay, say, teacher, I gamble. I got of gambler. Okay, I gamble. This one is acidic. Okay, I put alkaline. Jangan like that. Okay, so you must check doctor. Okay, check with doctor. Then doctor will tell you it's acidic or alkaline. Because doctor got staff to check. Okay, you got staff to check or not? I mean, if you bring liver paper with you, can. Vinegar mixed with jellyfish tastes good. How you Very good. You all sound like very familiar. Jellyfish and vinegar. I macam never eat before. It sounds poisonous. It sounds poisonous to me too. Omakase got wow. You all know omakase can you all got try before omakase. Oh, it's not very rich. Omakase also come out. Hase. Jellyfish can eat one man? Can. If you go Japanese food usually got jellyfish one. The jellyfish usually is uh like a transparent paper. Something like a transparent paper. You bite, okay, it's a bit crunchy one. Okay. Eat like with diarrhea? No lah. Okay. Okay, see video on online only. Omakase you see on video lah. Okay lah. I also never eat before, okay? Because every time I want to try omakase, I see the price, I rather go somewhere else. Okay, one person few hundred ringgit. Tak boleh tahan. Okay, so 1,000 plus, that one is normal price. Okay, I see cheaper also 300 per person, 200 per person. Even the cheapest I also cannot afford. I rather eat my Maggie. Okay. I eat uh my my what do you call that? The Korean noodle better. Okay. Okay, teacher, warp sting and bee sting, which one is alkaline, which one is acid? Warp sting and bee sting, okay, based on your hold on. Wait, my cat destroying my box. Oi, 不要咬啊. Okay, guys, let me scold her a bit. Okay, so on your syllabus last time, let me show you, because in your chapter 6 last time, okay, we got show you the example, okay, so the diagram one, if you remember. Hey, where's my this one? Okay, so we got warp sting, we got bee sting. Okay, so you may say, warp sting is alkaline, bee sting is acidic. So make sure you can memorize these two things also, because this thing came out in SPM 3 years ago. Okay, so maybe they will ask you in your coming exam, right? Not sure. So this one possible. Okay, so you have to like apply vinegar for warp sting, apply toothpaste, baking powder for your bee sting. Okay, so this is the idea of it. Okay, can teacher very rich, very good rich. You see my thing at the back. Okay, so back to the questions, yeah. Okay, this one. Okay, so we have your okay, this one, So after having your acid alkaline already, now moving on the next one is where you have ammonia dissolved in methylbenzene and dissolved in water in two different test tubes. We have a red litmus paper to test the properties of them. Okay, so now on this idea, what is this topic under? This is actually under the topic of what? The role of water to show your what? Acidic and alkaline properties. So if you remember when we write as definition for acid, we always say ionize in water, ionize in water, ionize in water, right? Because if you don't ionize in water, you don't get acidic properties. You don't get H plus ion out. So that goes to the same for ammonia also. So when ammonia not dissolving in water, he cannot dissolve one again. So basically, in methylbenzene, cannot dissolve. If cannot dissolve, means cannot ionize. If cannot ionize, means don't get you any alkaline or acidic properties. But for here, it's ammonia lah. So ammonia is what? Alkaline. So ammonia in methylbenzene, no ionize, so no alkaline properties. Your red litmus paper remain red. Then for ammonia in water, alkaline can show alkaline properties. Your ammonia can show alkaline properties. Your red litmus paper turn blue in test tube B. Correct. Okay, so now predict your answer and explain 6 marks. So 3 mark here, 3 mark here. So what do we say? So if I split them into like this title, so let's say test tube A. Okay, so first of all, what is your observation? So we say red litmus paper remain red litmus paper remain unchanged, or you can say remain red also can remain the same color lah. But why? Because ammonia cannot ionize in methylbenzene. So we say ammonia do not ionize in methylbenzene. Why? Because methylbenzene is not water. What do we call? Okay, what's the general term to call methylbenzene? Usually we call this the organic solvent. Okay, so does not ionize in methylbenzene. Okay, got one thing that you all always forget to write. Okay, because when you ionize, what you form? You form hydrogen ion, you form like all the ions. So ions is the particle. So if you never ionize, you also must tell me what type of particle you form. So if you never ionize, your ammonia is what particle? So we got 3 type of particle in our brain: atom, ion, molecule. So ammonia, if never ionize, no ion, is molecule. So we say and remain, or you can say exists as neutral molecule. Okay, and what is that so? So what's the final answer? We can say absence, so it means don't have absence of hydroxide ion. Who's hydroxide ion? The OH minus. Don't have OH minus, does not show any alkaline properties. Okay, can I write no hydrogen ion? Cannot, because this is not about acid. Hydrogen ion is relatable to acid. This is alkaline. Ammonia is about hydroxide. Cannot say hydrogen. Hydroxide can. Hydroxide can. Absence of hydroxide. Okay, then how about test tube B? So same lah. Test tube B, we have opposite observation. So we say red litmus paper turns blue. Why? Because ammonia ionizes in water to produce hydroxide ions. So, presence of hydroxide ions shows alkaline properties. Teacher, can I confirm is it alkali or alkaline? Okay, so you have to understand, okay, it's like acid and acidic, alkali and alkaline. Yeah, acid got acidic properties, alkali got alkaline properties. Okay, so one is what do we say? This is a kata nama. Okay, this is a description. Okay, what do I call this? What's the word in the end? I forgot. Properties is characteristic. Can say so. Yes, properties is characteristic. Okay, acid is very acidic. Alkaline is very alkaline. Yay, can say so. Okay, so acidic is a term. Okay, sorry, acid and alkaline is the name of the chemical, but acidic and alkaline is the properties of the chemical. Okay, can go toilet, go. If you want to go toilet, guys, don't have to tell me. Just go. Okay, so acid, alkaline, ionized in water. Yes, acid, alkaline, ionized in water. But cannot ionize in organic solvent. Teacher, this one right about hydroxide because ammonia is alkaline. Correct. Because ammonia is alkaline, so we talk about hydroxide. We don't talk about hydrogen. Hydrogen is when we talk about acid. Okay, can I add methyl benzene is organic solvent so ammonia can't soluble in organic solvent? Okay, you can add organic solvent this word, but you cannot say the word soluble. You must say the word ionize. Okay, must use the word ionize. Does not ionize or ionizes. Okay, so this one very, very important. The word ionize must come into play. Whether he ionize or not, you must use the word ionize. Do not ionize or ionizes. Yeah. Okay. So if this one okay, moving on. Okay, moving on, guys. I will choose another question because I got not much time left. Okay. I'll choose one question that is relatable to your salt, guys, because salt is one of the main thing that I very worried in exam. Let me see. Salt question in page number 94. Okay, page number 94. Okay, this one. Page number 94. Okay, so the other part that I'm very worried about for this chapter is where they give you a flowchart. This chapter, they love to give you a flowchart and give you all the unknowns, and your job is to become a detective Conan. To analyze and find who are all these unknown. Okay, but seems like fun, right? Seems like, oh, teacher, I can like analyze and do stuff, okay? But the problem is to analyze, your brain must store a lot of information so that only you can recognize who are all these unknowns. Okay, so you see, so with the flowchart here, guys, wait, let me do some water first. Okay, so with the idea here is here, when you do your flowchart now, always start from looking for any box or any chemical that arrow point out. Okay, arrow pointing out one, because that will be your number one. That is will be your first chemical. So here in the whole diagram, what is the chemical that is pointing out from everything? In the whole diagram, who is pointing out is the X. Okay, so it's the X point up to heat, point down to nitric acid. You get the idea? Can so that's the first thing you have to check. Point out one. Okay, point out. Solid X, very good. Solid X. Okay, but right. Okay, someone say solid X is PbCO3. Okay, see someone name call user. Okay, never give me the actual name also. Okay, never mind. He say PbCO3. Let's check how he realized it's PbCO3. Number one, if you read the question, gas Z is a colorless gas that turns lime water cloudy. What is the gas that can turn lime water cloudy? So with this, I think we all can agree with this gas is carbon dioxide. Very good. Yes. So we say this is CO2. Very good. Okay, but guys, if after heat got CO2, then after nitric acid also got CO2. Do you see? No matter what you do, you get a CO2. What can you think about? Your X got a negative ion, carbonate. Okay, guys, you all managed to understand why I get this? Because what is the negative ion that is always getting carbon dioxide? Is your carbonate ion. Okay. So if in future you see any question that gives you a brown gas and another colorless gas, which is NO2 and O2. If you see an experiment that give after you heat, you get NO2 and O2, you think about nitrate ion. Okay, so this is another possible negative ion that you can get from heating. Okay, so from here, this one you can throw away first. Okay, because here don't have okay. So the problem is now I know got CO2 after heat, got CO2 after acid. We know your X confirm got CO3 2 minus, but I don't know what is the positive ion. You get it? So how to see positive ion? If you see right now, okay, solid Y, any information? Did they give you any solid Y? They say solid X produces a solid Y, which is brown when hot, yellow when cold. Brown when hot, yellow when cold. Peanut, very good. Yes, guys, if you remember, for the color change based on temperature, we got two types. Okay, one is called peanut, one is called zebra. Remember what does peanut stands for? Don't give me peanut or teacher, PB. No, it's PBO. What is zebra? Not ZN, it's ZNO. Okay, so this is brown when hot, yellow when cold. Remember the color for zebra? The zebra is yellow when hot, white when cold. So that is the idea of it. So with this, okay, so this is the color change. So of course, with this idea here, okay, we have your one moment. Okay, so moving on. So now right here is brown and hot, yellow and cold. So we say that this PBO is our thread. Okay, it's the information we can get from here. So since you say let your solid Y is lead 2 oxide, PBO, can you backward predict what is your positive ion? So if you combine these two things together, it shall be your Pb2 plus, where this solid X shall be your PbCO3. Okay, so very good, guys. Those who can get PbCO3, congratulations. Okay, but no, they're not done. They're gonna add in nitric acid to get Q, to get reaction R, then Q add in R become a yellow precipitate that dissolve in hot water, and then we have a colorless solution. So before we start any question, let's continue on analysis first. Since we decided X is PbCO3. Okay, this one we settled it, can Then what is solution Q? PbCO3 plus nitric acid, you're going to write equation. So try your equation, you see, So PbCO3 plus nitric acid, swap your partner, become PbNO3 bracket 2, and again your H and CO3 get you H2O and CO2. Make sense, right? So with this, guys, you see, with this, you see, water got, carbon dioxide got, then who is the Q? PbNO3 2. So we say Q is PbNO3 2. We all agree on this, Then you take the PbNO3 2, you mix with R to get a yellow precipitate that dissolve in hot water. Guys, who is this? This one, recall a lot of stuff, yellow precipitate dissolve in hot water. Yellow dissolve in hot water. Yellow is correct, but zinc oxide is not soluble because oxide is insoluble. So ZNO cannot. This yellow precipitate is not ZNO. What else? How did you? We got learned before. Yellow precipitate that is in hot water, meh? Iron? No. Iron is not even yellow. Cannot. PbNO3 2, no. This one, very, very hard, let me show you where is it at. In your notes in Form 4, let me show you, let me show you here. In your notes in Form 4, where you learn the color, let me show you on my notes here. This one, So I believe you all remember, teacher, this one, peanut is PBO, brown when hot, yellow when cold. Zebra is yellow when hot, white when cold, right? Guys, see, you actually forgot. We have two other chemical that is soluble in hot water, and one is white, one is yellow. And who is the yellow precipitate that's soluble and dissolve in hot water? PbI2. Okay. You see this one very tricky, One small part in your syllabus, the whole page, you see, the whole page. Okay, you all remember peanut zebra, but you all cannot remember yellow precipitate that is soluble in hot water. That's why I say this chapter is not very hard. The hard part is your brain need to store a lot of stuff, to analyze all these things. So guys, this is lab 2 iodide. So it means on our question right here, guys, back to our question, back to your question, this yellow precipitate that is dissolving in hot water, this guy is PbI2. But what is R? What can be R? Guys, one thing. Number one, do you see that you are producing a precipitate? You are forming a precipitate, right? Forming precipitate is double decomposition. Why I want you to think about this? Because that is the method that can bring you to analyze your R. You have to think backwards, you have to think reverse, because now we know who is the product, but we don't know who is the reactant. So how to backward predict your reactant? Think about salt preparation. Okay, so what is the idea here? So it means, guys, on this part, I got Q plus R get me the yellow precipitate and the colorless solution, right? So I follow what I write here, Q plus R, you form yellow precipitate and colorless solution, right? So what are all these things? So since this is a double decomposition, this is double decomposition reaction, soluble salt plus soluble salt get you insoluble salt with another soluble salt, which is the insoluble salt right here is PbI2. So what is Q? We know Q is PbNO3 bracket 2. This is Q given by the previous analysis. But what is R? What is R? R must have Since your PB come from PbNO3 too, then your I come from where? Come from R. So R must have I. But what is the requirement for your R? Soluble salt. So I can go with Ki, NaI, sodium iodide, potassium iodide. Then I can swap my partner, become PbI2 and KNO3. So now, this is your final answer. And so your R is Ki, your Q is PbNO3. So as long as fun, correct? Yes, as long as your soluble salt is fine. Okay, so everyone will have different answer. I mean, it's possible different answer. Means can be Ki, can be NaI, can be ammonium iodide also can. The NH4I also can. But I will say Ki and NaI is the common answer lah. Okay, as long your R is a soluble salt with I is an iodide soluble salt, then okay. Okay, so guys, are you having fun with this analysis? You see? Okay. So technically, guys, just to analyze can eat up a lot of time. Okay. Not fun when cannot think. Yeah. If can think, you be like, wow, I'm a detective Conan. Okay. But then GG. You see, some people say fun, some people say no fun. You see, now you know this chapter actually very extreme one. People who love it a lot. People who hate it it's like throw this away. Okay. So if I got Conan brain, then I love it. Okay, half. Okay, come on. Yeah, so guys, let's try to answer. Identify solid X. So guys, who is X? Guys, identify means name. Name means don't give me symbol. This is a must skip question for me. Really, man? If this one question 11, how? Skip. Okay, so X is lead 2 is PbCO3. So lead 2 carbonate. Guys, to train you a bit, we also write the symbol PbCO3. How about Y is PbO? So lead 2 oxide. This is your PbO. If question say chemical formula, yes, then you only write PbCO3. Okay, then guess Z is carbon dioxide. This one we all know. Lime water turn milky, turn cloudy. Solution Q and solution R. So solution Q is lead 2 nitrate, which is your PbNO3 bracket 2. Solution R, solution R is the backward analysis, your double decomposition. So R can be potassium iodide, sodium iodide, that's up to you. As long as a soluble iodide salt. Guys, like this, you get 5 marks. Okay ma? Quite okay ma? I mean the analysis is hard but just by writing out the name, you get 5 marks. Compared to you go and write chemical tests. You imagine you go and write tests for nitrate, the brown ring test that we did in the beginning. That one get so many words get you 4 marks. Here you think, then you write name, 5 marks. Okay ma? So if analyze wrong, then wrong. So usually if you compare, I will prefer this one. Legit. I prefer this over writing out procedure. Correct not? Procedure you memorize so hard, then also cannot get full mark. This one you think, analyze, you got chance to get full mark. Okay, so I would rather this one come out in exam. But what if they come out both? You see, describe briefly a chemical test. But wait. The test for gas is Z. But I thought they say colorless gas that turn lime water cloudy. Huh? Lime water test yellow? This one what? Free mark? Hey! Okay, guys, come. So test for gas Z. Okay, so what do? We actually flow gas Z into a test tube containing lime water. Okay, containing lime water. And then number 2, your lime water turns cloudy. This one free mark. Channel. Channel also can. Flow also can. Channel and flow is the same meaning. Okay, 2 mark. So happy. Exam, can we write in this format? Yes. Exam in essay, you can write in this format. This is how exactly I will write in exam. On your test pad. Okay, 3 marks left. Okay, state the name for reaction 1. What is reaction 1? Which one is reaction 1? Oh, here. Oh, I saw it. I blind. So what is reaction 1? Just now we say it. It's a process where you use to produce insoluble salt, right? So we can say reaction 1, the name is double decomposition reaction. Okay, but guys, if they ask you name the method, don't use this because method name is called precipitation method. This one very specific. If you go and write precipitation reaction, wrong. Okay? Okay. If you go and write precipitation here in this question, wrong. Okay? This one consider wrong here. This one correct. Okay? Unless they say method name, then you go for precipitation. Okay? And lastly, write the chemical equation for the reaction. Guys, we already kind of write out already. So the chemical equation will be PbNO3 plus Ki. You swap partners, PbI2 with KNO3 and balance equation 2Ki, 2KNO3. Teacher, how to know it's which equation? This one, they continue. Name for reaction 1 and write chemical equation. So I just write this one. I follow from the same question. Okay, yes, it's continued from the same sentence. So I just reaction 1 chemical equation. So guys, you see, like this, 10 mark. Much better than writing out procedure mark. Procedure writing, memorize so many things, step 1, step 2, step 3, step 1, 2, 3, 4, 5, 6, 7, only can get 7, 8 marks. You see? Actually, if something like this come out in essay, okay one. Not to, I mean, it's suffering at first, but once you get used to it, it'll be something you prefer to do. Teacher can borrow my brain. You want my brain to go exam? Slow, wait. But I can bring this brain to exam with you together. When you go SPM, I go with you. But you cannot see my answer. Sorry, okay. Okay. So, so guys, next year I go SPM with you, okay? Don't worry. Teacher, may I ask, will chapter 8 come out a lot on exam? Yeah, I will say chapter 8 confirm come out one. So you must memorize chapter 8 stuff. Chapter 8, they will selectively choose a random topic one. But I can guarantee you confirm going to come out. Every year, last exam, your UASA, confirm got composite material, alloy, glass, ceramic. They will choose one thing to come out. Last year was helmet. Last year was bullet train. Last year was I think was glass. So confirm every year gonna have one thing come out from your chapter 8 one. Essay will come out. Essay these few years never come out but you never know. Possible. Possible essay. Because you know why essay possible? Last year SPM is essay. You know what they come out in essay? The essay, last question 11, the 20 marks last question, got 10 marks is chapter 8 form 4. You know what they asked? They gave us a table. They asked us to fill in the table. Reinforced concrete got what component? Optic fiber, what component? Photochromic glass, what properties? So they give you like a table that we see in our notes. Got like material, component, property. They got some provided, some empty. They ask you to list down the fill in the blank. So that is what they come out in last year SPM. Okay, 10 marks. So possible as an essay question. So I will say chapter 8, very important. Don't ignore chapter 8. Must study chapter 8. Okay, can so chapter 8 very famous in exam. Okay, so please don't avoid that. Okay, composite material will come out. Yes. Okay, can no chapter can be ignored. If you say like that, I never asked you to ignore any chapter, okay? I know. Chapter 1 can be ignored. You can ignore chapter 1. Okay. Bargain C, you got bargain B. Last year was bargain C. Last year SPM lah, bargain C. Okay. So I would say quite easy lah. I would say chapter 8 quite easy lah. So don't avoid chapter 8. Okay. So guys, still got a bit of time. Let me do one more question. One more question. Okay. Let us go to 97. This one. 97. Another flowchart. Okay. Look at page 97. Okay. Okay, teacher, all answers of revision pack are provided. Do you have answers at the back? No? Got don't have You flip to the back, see got answer no? Got should be at the back. Yeah. Okay, can Okay, so right here we have again, guys, find the guy that arrow point out. All point out. So who is this? Who's the guy here? Solid P. Okay, so solid P is the first guy. After heated, carbon dioxide gas. Do you see questions right here? Almost the same. So who is your negative ion? Carbonate. Okay now. But what is oxide of metal S? They never give you any hint, no color, no anything, okay? But they say after added acid, you form a colorless solution Q, and the Q got do tests for NaOH, ammonia, and brown ring. Brown ring test show you what ion is present. Brown ring is to test what negative ion. Brown ring test is to test nitric acid. No. I mean, if you are saying that acid T is nitric acid, correct. But the idea is brown ring is to test Q got nitrate. And if Q got nitrate, acid T is nitric acid. Can you all get to this idea? Sulfate, no. Sulfate don't have brown ring one. Brown ring test for nitrate. So if got brown ring form, got nitrate ion. If got nitrate ion, your acid T confirm is nitric acid. Because why? Because since P is CO3, how your P CO3 suddenly become NO3? Confirm the NO3 come from a T. Okay, you get the idea, you get how it works, then what's next? With this idea, we know all the negative ion, we know the acid, but who is the positive ion? So if you see plus NaOH, you get white precipitate form and soluble in excess. You plus ammonia, white precipitate form, soluble in excess. Guys, all these words, I always ask you guys to simplify into the format that we learned in our syllabus. What is the shortcut that we learned? White precipitate soluble, we call this WP with a tick. What is white precipitate form and soluble in excess ammonia? Again, a white precipitate soluble, white precipitate with a tick. So, two tests give you same result. Who is the positive ion? Guys, you know what table should we refer to? This is the table for your cation test. And what is the cation test? So if you forgot, let me go back to my notes again. If you go back to notes, test for cation is actually around here, the ZAPCM table. Okay, so if you remember, it's this one, the cation test 2. Okay, the ZAPCM table. So guys, who is the ion that can give you white precipitate soluble in both experiments. So what are the two experiments we see in our exercises now? We have plus NaOH plus ammonia. These are the two experiments we see in our exercises now, right? So let's refer to these two rows. White precipitate with a tick. This is ZAP. And then white precipitate with a tick on the second experiment is only under zinc, right? So who is the only ion that can give you white precipitate with a tick in both experiments? Is zinc. Okay now. Okay guys, you know how this table works, huh? Means you take your observation from your question, try to find who is the positive ion. Okay? So with this question, guys, means back to the question right here, we can say that with these two tests, your Q must have Zn2 plus. If Q got Zn2 plus, your P also got Zn2 plus. So what is P? So P, ZnCO3. What is Q? ZnNO3 bracket 2. What is R? Carbon dioxide gas. Okay. Because after you get carbonate, you get carbon dioxide gas after adding acid. Okay, guys. Is this clear? 5 mark. Free. Okay, not free lah. Okay, you use your brain ma. Okay, not free. Okay, you get what you actually work for. Okay. Okay. Still got S. Where's S? Oh, S. Okay, guys. Since we decided S, your P is zinc carbonate, right? So S after heated, it will be your zinc oxide. Okay, good. So we have your answer for P. Okay, will be zinc carbonate. Q, zinc nitrate. R is carbon dioxide. S is zinc oxide. And T, or acid T. So acid T, nitric acid. Okay, guys, this is how you can score 5 mark very easily in salt. Okay, so guys, if you really come out, that's why I say, guys, try to practice more. You realize this question, this flowchart is repetitive. Okay, it's repetitive one. You try to do more, you see almost the same one. Okay, so this thing will come into very handy if really come out in exam, easily score marks one. Better than description now, as I said. Okay, so what if they combine? You see, P react with T to produce Q, R, and water. Write a balanced chemical equation and describe the test. Okay, this 4 marks so easy. Okay, so what are the equation? P plus T become QrH2O. Okay, so we can have your P ZnCO3 plus T HNO3 swap partners. Your ZnNO3 bracket 2 with CO2 and H2O and balance equation. Okay, kind of simple. And how to test colors gas R? As R is the carbon dioxide. How to test? So we say flow gas R into test tube containing lime water. Okay, then we say lime water turns cloudy. Okay, can Okay, last one. A woman's arm was stung by a wasp. Why is wasp? Not bee, Wasp sting is what property? Okay. So just now we say wasp sting is alkaline properties. So he said she uses material X found at a house kitchen to relieve her pain. So what do you use from a house kitchen? Something that is acidic, no? Don't say, teacher, hydrochloric acid. Guys, your kitchen got hydrochloric acid. I don't believe. Okay. So cannot, we're gonna use vinegar. Okay. So name material X, you can write vinegar, you can write ethanoic acid, and explain how this material relieve her pain by same as just now lah. So vinegar is a weak acid that neutralizes alkaline stink without causing skin irritation. Or you can say without corroding the skin, also okay. What is skin irritation? Skin irritation means itchy. When something corroding your skin, you feel itchy. Then you have peeling skin. So that one is called skin irritation. Okay, guys. So today I cover a few things. So I cover acid alkaline, role of water, ionize in water, do not ionize in organic solvent. Can write pain. Pain for what? Without causing pain. Without causing further pain or further damage. Okay, can accept. Okay, because she memang pain already mah. She memang in pain already. So if you can say without causing further pain, it's okay. Okay, so once again, guys, I covered acid, alkaline, and neutralization, and also what else? Role of water. Okay, we have your strong acid, weak acid, strong alkaline, weak alkaline. Okay, all this, almost everything in acid, alkaline, I cover everything in here. Got one thing I know I cover, guys, is your standard solution. So if you all want to practice, okay, don't miss out standard solution also. And then in salt, I also almost cover everything. I cover solubility, I cover preparation of salt, but I never cover most of us. I never cover everything lah. So like I teach you how to do double decomposition, but I never teach you what is the soluble SPA and the soluble non-SPA. That one I never do. Okay, because not enough time. Okay, guys, 2 hours. I don't expect to cover the whole chapter again. If you remember, we used 3 months to cover this chapter. Okay, so 2 hours is a revision only. So salt layer, I covered solubility, I covered preparation. I also covered a bit of color. If you remember just now, I teach you the color brown and hot, yellow and cold, and who is the one that is yellow precipitate that dissolve in water, hot dissolve in hot water, that one color. And then we also talk about cation test, anion test, but I also never cover everything. I never do color test for like Fe2 plus, Fe3 plus. That one you have to use the potassium hexacyanoferrate 3, potassium hexacyanoferrate 2, okay, all this I never cover yet. So still got stuff that I never cover in here. Okay, so you don't say, teacher, oh, now I'm very good in this chapter already. I ignore this chapter in my revision. I can do this already. Guys, not done yet. Okay, this one still got more. Okay, so of course, the rest you can do it yourself, and of course you can try to check answers. If you really cannot understand the answer, then you can WhatsApp me. Okay, but guys, I tell you beforehand, I don't want you to send me question and ask me, teacher, how to do. I don't want question like this. I want you to do it, and then if you don't understand, you ask me why is this answer like that. Okay, I want you to try to do, and then you don't understand, you ask me. You don't take picture, come to me, teacher, how to do this question. Hello. If like this, you just might as well you just ask ChatGPT. Okay, you just refer to the answer marking scheme. So I want you to try. Okay, you only ask me when you really don't understand. Okay, don't just empty question come to me. Okay, can so guys, recently I got many questions, students like this. Teacher, take picture. You take picture of 5 questions. Teacher, how to do all this? Hello, I give you answer straight away better lah. Okay, so please make sure you all come to me with questions, quality questions. Okay, I want you to ask me why like that, why this, why like that. Then I will answer you. Can non-TTC student message me? Can, because I wouldn't know whether you TTC or non-TTC unless we got interaction okay? If a random people come and ask me question, I will also answer one. But don't too much lah. Okay, I will still answer even if I don't know who you are. Okay, don't worry about that. Okay, teacher chapter 7, chapter 7 today don't have, because I realized this book don't have chapter 7. I was checking yesterday night. Chapter 7 don't have. So today I mainly do chapter 8. Sorry, chapter 6. Chapter 6 is what I focus on today lah. Tonight also got class. Guys, tonight those who having class with me on normal class same time same time. What time Same time. Tonight same time, 8:05. So today those who having normal class with me see you tonight again I taught extra class to replace the normal class. Oh, you forgot the TTC usual class? Ah? Wait, no lah, wait. TTC usual class still ongoing, okay? Teacher will do chapter 7 ma. Chapter 7 not here. Chapter 7 I do other class. In normal class. In normal class I do okay, in normal class I plan to do chapter 4, 5, 7. Okay, so these three I usually I plan to do in normal class. So extra class I only do chapter 6. Okay, if normal class cannot cover chapter 7, I organize another extra class. Okay, so maybe on I will see how this week goes. Okay, because your exam is on 30th ma. Still got next week. Okay, maybe coming Sunday. I organize one more time. Okay, you all refer to GC or WhatsApp group lah. Can for chapter 7. Okay, see me tomorrow. Okay, I see you tomorrow. Okay, can chapter 5. Yes, chapter 5 I will do in normal class. Okay, chapter 5 do in normal class. I organize like Wiling 11. She crazy one. She 11 hours. I cannot. Okay, come guys. Okay, can so if okay, then I will see you again tonight. If you're not my student, it's fine. Okay, okay. I will see you when I see you. Okay, anything just WhatsApp me. Okay, can you want to go physical class? Okay, can tomorrow I see you if I see you. Okay, teacher, this one got recording. I will post on my YouTube. Okay, you go my YouTube and watch if you want to replay. Can so if okay, guys, thank you for coming in early morning 8 a.m. Class. Teacher later got physical class. Got later class as usual. Okay. If you later got class with me, everything as usual. Can okay. Thank you guys. Thanks for coming. I'll see you all when I see you. Okay. Bye bye. Bye bye. Early bird takes the chemistry. Yes, correct. Bye bye. Bye bye. Bye bye. Bye bye. Bye. Bye guys. Bye guys. Bye bye.